In this video, I'm going to work a few problems for the lever equation. If you look at the top of the screen, I have the equations. The work in equals work out, which we covered in the PowerPoint, which can also be considered work effort equals work resistance. And so we can break that down into the work problem. All right? Force times distance of the in, or your effort, equals force times distance of the out, which is also your resistance. All right, so AMA is the force out over force in, and IMA is the distance in over distance out. So let's work the first problem. Okay, so Eric is using a lever to lift a 20-kilogram box, which lies a distance of 0.5 meters from the fulcrum. Eric pushes down on the lever with 50 newtons of force. What distance is Eric from the fulcrum? So first we need to look at this 20-kilogram box. 20 kilograms is a mass, not a force. So I've got to convert this into force. So to convert it into force, I have to take the mass, kilograms, times meters per second, which is 9.81 meters per second squared. If you remember, we talked about what a newton equals. A newton equals a kilogram meter per second squared. So in my kilograms, I'm going to say 20 kilograms times 9.81. We'll work that out on your calculator. Right, so that means that this box's force, which is going to be my resistance, is equal to 196.2 newtons. All right, so I have my force resistance, and it lies a distance of 0.5 meters from the fulcrum. All right, so that means that my distance resistance equals 0.5 meters. My unit is correct because, remember, a joule is a newton meter, so I have to make sure that these are in meters. Eric pushes down on the lever with 50 newtons of force. So that means the force of the effort, or again in, equals 50 newtons, and that one's in the correct unit for me. So what distance is Eric from the fulcrum? So I want to know my distance effort would equal my question mark. All right, so let's look at our equation. Okay, it says force in, distance in, equals force out times distance out. All right, so I plug it in, 196.2 newtons times 0.5 meters equals 50 newtons times x. So I know my handwriting is bad. Hopefully yours looks a little better on your screen. But I'm going to multiply 196.2 times 0.5. And then I'm going to divide that by 50. So the distance of my effort, is 1.962 meters. And on this one, we're not going to talk about significant figures because it is only one significant figure. So in that case, if your teacher does want you to go with significant figures, it would actually be 2 meters. Noticing that here I have one significant figure, and here I have one significant figure. Okay, so let's move on to the next one. All right, so what is the IMA of the lever? All right, if you remember, IMA, move this up, Okay, let's look back up here, IMA. So IMA equals distance in, okay, let's look back here. Our distance in is our effort, and that is what we just found. All right, so 1.962 meters over distance out, which if you look back at our equation here, our distance out is 0.5 meters. 0.5 meters equals, I'm going to divide 1.962 divided by 0.5, and I get 3.924. Again, if we're looking at significant figures, we would round that on to 4. Okay, notice for the IMA and AMA, there's no unit. These meters have canceled out. Okay, so let's look on to the next one. All right, so what does this number mean to you? This number means that it is 4 times easier to lift that box because you put it on a lever system. You increased your distance, so you decreased your force. So what is the AMA of the lever if Aaron actually pushes down on the lever with a force of 70 newtons? What does that number mean? Okay, so AMA our equation for AMA is force out over force in. Okay, so I have the force of the resistance is my out, so that's 196.2 newtons. And on the problem it says that my effort is 70 newtons. Excuse me, I'm sorry, 75 newtons. Alright, so that means my AMA is, let's plug it in, 196.2 divided by 75. It's 2.616. Okay, in this case I have 2 significant figures because I have 2 here and 1, 2, 3, 4 here. So significant figure-wise, I would have 2.6. Again, I do not have a unit because newtons cancel out. Okay, so what does this mean? That means actually with friction and everything else added in, you have 2.6 mechanical advantage. So it's 2.6 times easier to actually lift that box. And the next one, what is the efficiency of the lever? What does this percentage mean? So efficiency is always AMA over IMA times 100. That's going to give me my percent. So my AMA was 2.6, my IMA was 4 times 100. So let's plug that in. Okay, after I plugged it in, 2.6 divided by 4 times 100, I get 65%. All right, so my efficiency was only 65%. All right, so that means we've lost some of our energy to maybe heat or friction or something like that. So, okay, I'll make another video also with some more practice problems if you need some more help.